Ciao, Algebra 2. In this video, I am going to be teaching you how to determine the equation of a polynomial's graph. So, you've already learned how to graph, so now we're going to go the opposite way. So you want to start by taking notes on these steps. Right. Oops. Okay, so steps for determining the equation. Step 1. So the first thing you want to do is list the roots. So when you list the roots, that's the x values of the x-intercepts. And kind of like a 1a step, take a note if they're single, double, or triple. So how is it going through the graph? Is it going straight through? Is it bouncing off? Or is it flattening out? Step 2. How do you like this drum solo in the music I'm listening to? I don't know how well you can hear it. Write in factored form. So this is like what we did in the last chapter. So that's going to look like p of x equals a, and then we're going to have a bunch of factors, x minus m, x minus n, I don't know. Could keep going, it depends. The important thing is to take note of there could be an a value. So step 3, we want to substitute in a point for x and y to solve for a. And then once we have a, step 4 is to rewrite your final equation. Okay, so if you need more time, you can pause the video. Make sure you get those steps written down, they're important. And then let's do an example. All right. So in this example, we are going to algebraically create a function that fits the graph. All right, so I'm going to make my scale 2 so that I know I can fit everything. And we're going to go up to +8 and down to -8. So 6, 4, 2, 0, negative 2, negative 4, negative 6, negative 8. And 2, 4, 6, 8. Careful when you have a scale change. 2, negative 4, negative 6, negative 8. Okay, straight edge. Okay. And now we need to plot some points and then do your best to make the graph like mine. So let's plot the points negative 4, 0, negative 1, 0, so they'll be right in between, and positive 3, 0. Okay. And then negative 3, negative 9. So this is negative 2, so negative 3, negative 9. And that one I'm going to label. Okay. And now our end behavior is going to be up, up, and we're going to intersect like this. So make sure you graph this accurately. I'm doing it in pen, so hopefully I don't mess up. So I want us to go straight through here. And bounce off. Don't forget your arrows. Okay, so step 1, list the roots of the function. So those are the x values of the x-intercepts. So I'm going to go to my graph. And I'm going to look. And where are my roots? So we have 1, 2, 3 of them. So I have x equals, remember your scales, so x equals negative 4, x equals negative 1, and this is 2, so this is x equals 3. Also, I told you it was. And then we want to note if they are single, double, or triple. So that's based on how they intersect the graph. So because this is going straight through, it's single. And now you could do this a couple ways. It depends on what you like. We could draw a little picture to remind us. So this is going straight through, right? This is going straight through, and this is bouncing off. So we have a single, and a double. And that's going to help us determine the exponent. So now we want to write this in factored form, so we need to turn each of these into factors. So this will be, you can just add it to the other side, so it's equal to 0. And then make a function. So I'm going to call my function f of x. We don't know what the a value is, but I have x plus 4, x plus 1, and x minus 3. But this is not correct because of the multiplicity, right? This is going straight through, this is going straight through, so the exponents have to be 1, and this is bouncing off, so it's going to be double. And we're going to do the lowest possible exponent, so you'll only ever have an exponent of 1, 2, or 3. Okay, so now we're on step 3, and that's why I gave you this point. We now need to substitute in the xy point and solve for a. So I'm going to replace f of x with negative 9 and x with negative 3. Please do not skip steps. You need to show algebra. So negative 3 plus 4 is 1. Negative 3 plus 1 is negative 2. Negative 3 minus 3 is negative 6. Negative 6 squared is positive 36. All right, I'm going to multiply all these together. So 1 times negative 2 is negative 2. Negative 2 times 36 is negative 72. So this will be negative 72a. And when I divide, right, I want to get a by itself. So I'm going to divide both sides by negative 72. And I think some of you should start showing this step because a lot of students have been messing this up. The numerator is smaller, so this is going to be a fraction. It's negative divided by a negative, so it's positive. And 9 over 72, they're both divisible by 9. 9 divided by 9 is 1. 72 divided by 9 is 8. Leave this as a fraction. Basically, guys, you always want fractions when you're solving algebraically. There are a few exceptions in algebra where we want decimals. Alright, so now I've got my a value, so I'm going to rewrite my equation in factored form. So f of x equals 1/8 times x plus 4 times x plus 1 times x minus 3 squared. And I am done. Now, you could do a check by checking a few things, right? So you could check by doing a leading term test. And checking potential turning points and zeros. So, if I do the leading term test, right, the degree of this, so I'll just do a quick check, I have a little bit of time. So the degree of our polynomial, we have to look at it in this factored form, so it would be 1, 2, right, so this would be squared, this is just x, so that would make this cubed, and this would be to the 4th. The leading coefficient would be 1, oh, just kidding, would be 1/8, because if I multiplied all these out, it would just... So that means that my end behavior, because it's even and positive, should be up, up, which it is. And then just double check like your zeros. So -4, so +4, -1, +1, -3, going straight through, exponents 1, straight through, squared, bounces off. So it seems like everything checks out. And we are done.